These are not the exclusive problems with this model. There are others as well. Let's talk about a few. Early on, it was realized that one of the implications of the Big Bang is that there should be particles that are magnetic but only have one pole. So not north and south on the same thing, but only one. The problem is we don't see any particles like this in the world around us. The Big Bang, however, Big Bang model said that there should be plenty. So this was a serious problem for the Big Bang. It made a prediction that did not match the universe. There's also something called the horizon problem, where in measuring the temperature as represented by the microwave background that was discovered, the map turned out to be too smooth. There are parts on opposite sides of the universe that appeared to be very close to the same temperature, even though under the Big Bang model they couldn't have equalized temperature across those two locations. And I won't discuss that in detail because too much detail. For now, we'll just say this is acknowledged to be a serious problem for the Big Bang. There's also something called the flatness problem. Cosmologists model the geometry of space, and what that means we'll just set aside. We'll just acknowledge that that's what they do. And they were arguing over whether space would be this shape or this shape. I should say universe rather than space. But what surprised everybody was it turned out to be flat, which is near impossible in the standard Big Bang model. The Big Bang model should have gone way this direction or way that direction. It couldn't have stayed in the middle, but that's apparently what it did under their way of interpreting the universe. Around 1980, a cosmologist named Alan Guth found a solution to all three of those last problems. It's called inflation. What is inflation? Well, inflation is the idea that early on in the history of the universe, that tiny speck of brand new universe suddenly started inflating at a very rapid speed, much higher than the speed of light. And why it did that, well, we don't really know that. It was done by a particle called the inflaton. Well, what is the inflaton? You ever seen one? No. Where does it fit in the model? Well, it doesn't. But it must exist because otherwise those three fatal problems for the Big Bang remain. And this solves the three problems, therefore it must be true. Once you start inflation, how do you stop it? Well, we don't know that either. The universe isn't inflating today, so it must have stopped, but the model says once it starts, it doesn't stop. As an article in Astronomy Magazine pointed out, as to what drove inflation, nobody knows. Physicists have suggested a long list of models to describe the inflating universe, but most of the proposed solutions are mathematical conveniences with no particular physical basis. All the theories of inflation amount to proof that we don't have one good theory yet. So is inflation a good scientific hypothesis, or is it a Band-Aid? A hand waving saying, well, this must have happened and done such and such because it solves big problems for us, even though the such and such itself doesn't have a good basis.